Before we begin with the iso and neo common name lesson, I want to explain a little bit more about isomers, in particular about constitutional isomers. From a normal alkane lesson like this, we saw that isomers were compounds that have the same molecular formula but are different in some way. And in particular, constitutional isomers are compounds that have the same molecular formula but the atoms are not connected in the same fashion. So let me illustrate this by actually changing the program over to line view and drawing some carbon containing compounds. So from the previous lesson we saw that the 3-carbon chain was going to be referred to as propane. Now if I take propane and I consider just adding one more carbon on this edge right here, then I can just go from propane to actually butane. And keep in mind right now I haven't added any of the hydrogens I haven't added any of the hydrogens. Now let me take this picture now and let me go ahead and add another carbon up here. So it's again propane plus one more carbon, okay? And this compound right here is actually called isobutane. So let's write down these two names. This compound is what? Normal butane, which most people just call butane. And this compound right here is called isobutane. And the reason why it's called isobutane is because if you count the implicit number of hydrogens that these compounds have, they both have the same number of hydrogens as they do the number of carbons. So both compounds have what? 4 carbons, and both compounds also have, if you count with me, okay, 3 plus 2 plus 2 plus 3, and that equals to 10. So we say that both of these compounds, butane and isobutane, are C4H10 isomer. Let's prove the same thing down here for isobutane. For isobutane, there's 3 hydrogens here, 3 hydrogens here, 3 hydrogens here, and 1 hydrogen here, for a sum of 10. So again, these compounds are called isomers. In particular, they're called constitutional isomers because the atoms are not connected in the same fashion, but both compounds have the same molecular formula. Now, let's take these two butane isomers and let's generate actually pentane isomers. So to do that, I'm going to take this picture and I'm going to add another bond over here. So I'll just draw butane again and I'll add a new bond over here. Then I'm going to take butane and I'm going to add a new carbon bond over here. Okay? So both of these compounds have 5 carbons. So the top compound right here again is called pentane or normal pentane. And the second compound down here we're also going to call isobutane, or excuse me, isopentane, because it has 5 carbons. Okay, and also because it's a what? An isomer of pentane. Both of these compounds have the same molecular formula. If you count up the carbons, like we did right now, we have what? 5 carbons, and both of these compounds have 12 hydrogens. You should test that you can actually count that you have 12 hydrogens on both these compounds, just like I did for the butane isomers. Okay, now, after this, if I were to take the butane compound, so let me go ahead and do that, okay, or normal butane, and add a new carbon bond over here, we start actually repeating structures. Okay, can you see that in some way this compound is equivalent to this compound over here? Okay, so it's not necessary to draw this picture again. So I'm going to go ahead and do several undos over here. Okay. And so for instance also, if I go ahead and take butane and add another carbon over here, I hope you can see that I would have generated pentane again like here. Now if I take this compound and I add another carbon bond like this, okay, I hope you can see that this compound is actually equivalent to this compound over here. So let me undo that. Okay, and then the other choice is to take this compound and add a new carbon over here. Now if we look at that compound, it actually is a new structure. So let me go ahead and draw that compound out. Okay? Okay, this compound down here, it has the same formula as the other two compounds. It's a new compound. It's not butane. It's not isobutane. Okay, and so just like on the Matrix movies, this is actually neopentane. okay, or a new pentane isomer. You should test for yourself also that this compound, even though it has 5 carbons, it still has, 12 hydrogens. And that can easily be done by considering that I have actually 4 methyls in this compound. So 4 times 3 is equal to 12. So again, pentane, isopentane, and neopentane are constitutional isomers. They all have the same molecular formula, but the atoms are connected differently. And so basically that's what this lesson is about, to learning how to differentiate between isobutane and neopentane. So to do that, let's keep on generating isomers of compounds that of alkanes actually. These are called acyclic alkanes, like that have now 6 carbons, and they actually have 14 hydrogens. Okay, to do that, let's go ahead and do like we did before, and let's take pentane and add a new bond to it at different positions. Okay, so first of all, we can generate hexane, or normal hexane. Okay, next we could go ahead and add a new carbon over here. Okay, and after that, I could go ahead and add a new carbon to this picture. So I'll draw pentane again. Okay, and add a new carbon over here. Now in the second structure, I hope you can already see that this is actually iso. Okay, isohexane. And you may be wondering, well, how do I know that's isohexane like this? And the answer is, well, for an iso group like there, or for an iso compound, what you'll look for is you'll look for a methine with 2 methyls attached. So this should actually look like a victory sign. Okay, again, it's a what? A methine with 2 methyls attached. So in this structure again, I have what? A methine with 2 methyls attached. In this case, I have a methine, but I only have what? 1 methyl attached. And we actually don't have a common name for this compound right here. So eventually, after these lessons, or after this particular lesson, we'll have to start learning how to name these compounds systematically. Let's go ahead and try to generate some other isomers from here. If I go ahead and add another methyl over here, I hope you'll see that what we will have generated is the isohexane again. How do we know that? Well, that would be what? 2 methyls. Let me go ahead and add it in here right here so you can see. It would be what? 2 methyls and a methine. Okay, so that's not a new structure. And if I add a new carbon over here, that wouldn't be a new structure either. I will have just generated normal hexane again. Okay, so let me go to the next picture over here and try to add a new carbon. For instance, if I add a new carbon over here, like so, I hope you see that this compound and this compound are the same. Okay, next if I add a new carbon over here, okay, if I add a new carbon over here, that somehow is similar to this compound. Remember, this one was called isopentane. So we're going to also call this one an iso variety. So this one we're going to call, well, actually, sorry, this wasn't called isopentane. This was called what? Neopentane. So if this is neopentane, we're going to call this one neohexane. And how are we going to identify whether something is neo? Well, what you're going to look for in a neo compound is a quaternary carbon. And quaternary carbon refers to a carbon that's attached to 4 other carbons. And 3 of those carbons attached to them have to be a methyl. So in this compound, I have a quaternary carbon and I have 3 methyls attached to there. Another way of thinking about this is that this is basically a carbon that has a little peace sign on it. Okay, it has 3 little fingers on the peace sign. Okay, so I've managed to generate the isohexane, and I managed to generate also neohexane. Remember, this compound, we didn't have a name for it, a common name for being able to name this compound. Question is there any other isomers that I could generate by starting off with these compounds? And the answer is yes. I can take this compound and add another carbon over here. So let me go ahead and do that. Okay. And this compound, again, it doesn't have a common name to it, so we'll have to learn systematic nomenclature to learn this. Okay, and finally, if I had another carbon over here, I would actually be generating the iso compound, or the isohexane, just like this compound over here. And if I add a carbon to any other, or another bond to any of these other carbons, for instance, if I do this, then I hope you can see that this compound would be equivalent to the neohexane. Okay, so let's review a little bit. So there's only one propane isomer, okay, or one normal propane isomer. There's actually two butane isomers. There is 3 pentane isomers, and then there is 5 hexane isomers right there. If you go beyond 6, okay, you can continue with the same pattern for generating new isomers. Okay, the combinations actually start exploding. For 7 carbons, if you work in flatland, there actually would be 9 isomers. Okay, and all those compounds, let's write those down. Okay, all the C7H16 isomers like this. In total, you would have a total of 9 in flatland, and eventually in 3 dimensions, we'll go ahead and show you that there's actually 11 3-dimensional structures that we can come up with. Remember, all these compounds right here are what? Are isomers, because they have the same molecular formula, but the atoms are attached in a different fashion. Okay, with this introduction, let's go ahead and start the lesson and just show you a few structures. Okay, we're still in line view. So if you don't like that view, let's go ahead and go to Pollen 2. And when you look at this compound, you just have to decide, is this or if you want, we can go ahead and toggle the hydrogens off and go back to line view, since this is how we were looking at this compound. Okay, and hopefully you'll be able to see that this compound is actually iso. Why is it iso? Because it's a methine with 2 methyls on it at the end. So this is iso. And now all we have to do is we have to decide how many carbons we have in the structure. So we can count them up: 1, 2, 3, 4, 5, 6, 7, 8. So this is actually an isooctane compound. Okay, and we put the extra O in there. We're actually going to pronounce this in 2 syllables, or more than 2 syllables, and it's going to be isooctane. So let's go ahead and press continue. Okay, isononane. Okay, what do we need to do for isononane? We need to have a methine with 2 methyls on there. And the rest of the structure is just so that we can add up to 9 carbons. So we have 3 so far. So there's 4, 5, 6, 7, 8, 9, and that's it. Okay? 3, 4, 5, 6, 7, 8, 9. Okay, we'll go ahead and add the hydrogens. Go ahead and toggle arrange. And we'll go ahead and fit the structure on the screen. And that should be it. See if we can find a neo example right here. Okay, just what we were asking for. Here's a neo example. If it's too busy with all the hydrogens on there, let's go ahead and hide the hydrogens. And I hope you can see the P sign, the 3-pronged P sign, where you have a quaternary carbon, right? A carbon that has 4 bonds to carbon, and you have 3 methyls on there. So we can go ahead and call this what? Neo. And all we'll do now is go ahead and add up the total number of carbons, so we can tell which isomer of which alkane or normal alkane this is an isomer of. So the answer is I have 4, 5, 6, 7 carbons on here. So this is neoheptane. Okay, now let me go ahead and show you the hydrogens. Okay, under toggle show right here. And when I show you all the hydrogens on here, what I want you to do is add them all up. And so here's 3 plus 3 plus 3 plus 2 plus 2 plus 2. Okay, and so that should be 6, 9, plus these 3, 12, plus 4 more. That should be 16. Okay, so the real name is neoheptane, like that, and it should have 16 hydrogens. Well, if you were to do the same thing with the linear chain, now we've already named this compound, so I'm going to go ahead and erase what's on here, like that. Okay, I just want to show you again that, okay, if I have 7 carbons, 1, 2, 3, 4, 5, 6, 7 carbons, and I add the hydrogens, okay, and you look at this, it's called an acyclic compound because there's no rings in there. okay, and it's called a saturated hydrocarbon. Okay, saturated because each one of the carbons has the maximum bonds it can have, or maximum number of atoms that it can have, which is 4. Okay, and hydrocarbon because it just contains all carbons and hydrogens right here. So anyway, if you look at this compound also has 7 carbons and it has 16 hydrogens on it. Okay, just prove it to yourself. This is what? 3 plus 3 plus 2 plus 2 plus 2 plus 2 plus 2. Okay, if you don't believe me, go ahead and look at the info window. Go ahead and press Sigma Framework only no, just to count. And there it is, 7 carbons, 16 hydrogens like that. So again, this compound, neoheptane and normal heptane, are constitutional isomers of each other. They have the same atoms, but the atoms are attached in a different fashion. Okay, I got it correct, not because this corresponds to that, but because the picture I was given corresponds to neoheptane. Okay, I'll just show you a few examples, more examples. The lesson is quite simple, so I don't have to show you that many examples so you can get 100 on this. Okay, let's look at this structure. Let me fit it, or let me make it a little larger. Let me go ahead and roll it on the screen so you can see it a little better. Okay, if that's too cluttered, then we'll go ahead and hide the hydrogens. And again, this is a neo example. Neo because it's a carbon, or quaternary carbon that has what? 3 methyls, and the rest of the structure is just a carbon chain right here. So I have 4 carbons, 5, 6, 7, 8. Okay, so this is a neo-octane isomer. And again, it has 8 carbons. And I hope you're seeing a pattern also when we're doing this right here. And I hope the pattern that you see is that, okay, I have twice as many plus 2 hydrogens. What does that mean? Okay, since I have 8 carbons, then I have twice as many hydrogens, so that would be 16 plus 2, okay, and so that would be a total of 18 hydrogens in this structure right here. Okay, again, if you don't believe me, let's go ahead and check it out. Okay, go to information, and I have 18 hydrogens in the structure. Okay, and the reason why that is, okay, again, I've already named this compound, so I'm going to go ahead and erase right here. Or the thought experiment that you can go through to prove to yourself that this compound has 18 hydrogens. Okay. Okay, so here we have what? 6, 7, 8. Okay. Is that you can consider each one of these carbons to actually be like a methylene. And then at the terminal methyls right here, you have an extra hydrogen. So let's go ahead and add everything right there so you can see what I'm talking about. Okay, so you can see that each one of the carbons I have what? I can consider even this carbon to be like a methylene with an extra hydrogen, which is really a methyl, not a methylene. And on this carbon, I have a methylene, this carbon's a methylene, this is carbon methylene, methylene again, methylene, methylene, and again here at the end I really have a methyl, okay, but I'm going to go ahead and call it a methylene with an extra hydrogen, okay, so that you can see that where did I get the 18 hydrogens? Well, 18 is equal to 8 times 2 plus 2. Okay, because I have what? 8 methylenes plus 2 extra hydrogens at the end. Okay, now I keep on calling these methylenes at the end, but remember, these aren't not methylenes, these are called what? Methyls. Okay, let me erase this extra notation right here, and let me press continue. Okay, and here's another one. Okay, now this particular one is a little challenging for people or for students to get right here. Okay, and even though we gave this compound, remember there was only really 2 butane isomers. This is a butane isomer, right? An isomer of normal butane. Okay, and you can check again. Let's see, we were talking about the formula, right? Since it's a butane isomer, it should have, okay, 2 times 4 plus 2 hydrogens on it, and that should equal to 10. Okay, so it is a normal butane isomer right there. Again, you can prove it to yourself by saying, well, I have what? 3 methyls, so 3 times 3 is 9, plus 1 is 10. Okay, now since there was only 2 butane isomers, and one of the ones butane, the other one must be what? Isobutane. Okay, and the reason why this one might be a little confusing, and you might at first have thought, okay, this is an isobutane, this must be what? Neo. Why? Because it looks like it has a P sign, right? I have a carbon with 3 methyls on there. But remember, for neo, what we needed to have is a what? A quaternary carbon. Okay, this carbon is called tertiary because it's a carbon attached to just 3 carbons, and it's also called methine, remember, because it's a carbon attached to what? To 1 hydrogen on here. Okay, so for that reason, we're not going to call it neobutane, we're going to call it isobutane. Okay, and that should be pretty much it for the lesson like that. I won't go through the rest of it. It's really straightforward. The most important thing that you can get from this lesson is understand what are constitutional isomers. Constitutional isomers are compounds that have what? The same formula, but the atoms are connected in a different fashion.